Classification is required because we have to analyze the large volume of data that is available in data science. The base classification method, also the next algorithm that we can see here is rule-based algorithm. So these are the few algorithms that will help with respect to classifications. There might be chances of selecting the irrelevant or the redundant data which directly affects the performance. The classification is a supervised learning technique that is used in the data science. Hello everyone, I welcome you all to the first session of Unit 4. Yes, we have completed 3 of the units and we are starting with 4th unit. 4th unit is all about classification and that's under the subject none other than fundamentals of data science. Great. Over here, my name is Deepa Kutnekar. I'm working as an assistant professor in the Department of Computer Science, Vidhyaashram, Temple of Excellence, Mysuru. Let's move forward and understand what are the things that we discuss in today's session. So as the name of the unit specifies, that's classification. So initially we will be understanding like why classification is required, then what is classification with respect to data science. Then we will be discussing like what are the basic terminologies that has been included under classification. Following, we also do discuss what are the issues as well as the process that is involved in classification. So these are the things that we discuss under classification. Now, we do know that we have to classify our data, correct? So in order to classify that, we need some criteria, or the classification will become more easier when we have a supporting process, which is none other than algorithms. So we are heading with the different algorithms that can be utilized in order to classify our information, that is classification under data science. So these are the things that we discuss in today's session, and under algorithms, we will be discussing 2 of the main algorithms, that is none other than a decision tree induction, and the second algorithm that we discuss in today's session is the attribute selection measures. So these are the 2 algorithms that we discuss in today's session, and in the similar way we have multiple algorithms that we see in our further sessions too. All right, so let's move forward and understand like why this classification is required. Classification is required because we have to analyze the large volume of data that is available in data science. Thus we have to move forward with classification. Now let's understand like why this classification is required. In order to identify various patterns and in order to make predictions. Also, this classification will also help in making decisions. So these are the things and they are very crucial, isn't it? Yes, decision making is very, very important. Then the predictions, yes, even that is important with respect to today's era. And in order to make decision and the predictions, we need patterns, correct? So we need to identify proper pattern, which is none other than pattern identification. So all these things are must and should followed in order to predict or make the decision. So that's why the classification helps us to do these things in an efficient way. So this diagram depicts that a chessboard is there and there are various soldiers who are placed. By seeing the placement, we have to predict the next placement and we have to supposed to be take the decision by seeing the placement. So these are the things that we can expect, and in order to do this practically, that's with respect to a large volume of data, we have to step with classification. Thus we can say that the classification is most important technique that is used under data science in order to predict the categorical outcomes from the data. So this is all about understanding why the classification is required. All right, let's move forward and understand what is classification. The classification is a supervised learning technique that is used in the data science. This classification is utilized to assign the data objects to the categorical classes that are predefined. So that is the first thing that is required, and also the classification helps in learning the labeled historical data as well. Then further, it is also used to predict the classes or the class labels that can be utilized to study the new as well as the unseen data that is available in a data science. So let's consider an example of emails. For example, our mails will be completely filled. or we can say that our inbox will be completely filled with many mails, like few mails will be of spam and few mails will be of the informative or the some subject matter related things. So these are the criteria or the categories that we can consider. Also in our inbox of mail id, we can create a special category based on our requirement too, right? So which makes us very easy to track those emails. If we just go to that folder, we can track the multiple emails under those. If we go to the spam folder, we can see multiple spam emails. Then forward by the primary, in the primary field we can see the many useful emails that we have got from various sources. So this is how we can categorize our information so that it will be helpful for us to understand and predict as well as to make the decisions very easily. All right, let's move forward and understand the basic terminologies that is utilized under classification. The first terminology or the first term that can be used is a data set. Data set is a collection of data records. Okay. The second term that is used under data science is none other than the feature, or which gives us a attribute. It means like it gives us a input variable that is used for further predictions. So this is the first one, and second one is the feature or the attribute. Moving forward, the third terminology is none other than the class label, which gives us the information on the output category. Then followed by the next type is a training data. It provides the data which will be useful in order to build a model. So that is our next terminology, and the next last terminology is none other than the test data. Test data, as the name itself specifies, it provides the data that is required to evaluate the information or the data that is available. So these are the few terminologies that we can consider with respect to classification. Now let's move forward and understand like what exactly is the process that is involved under classification. We can't directly do the classification like, yes, this is my classified feature and this is my second attribute. So in order to do this, we have a set of format that needs to be followed. So let's move forward and understand that format, which is none other than the classification process. Now under classification process, there are two different types, or we can also say that there are two different steps. The first is none other than a training phase. Okay. Next one is none other than the testing phase. So the first one training phase, second one is the testing phase. Now let's move forward and understand what is all about this training phase. Yes, as we know, as the name itself says, we will be training or we will defining the categories or the attributes based on our requirement. And under testing, what we will do, we will evaluate whether the categories or the attributes that is formed or that is being trained under training process is proper, or is it sufficient, or we can also say that is that training models what we have built, is that the same thing that we need, and is it according to the standard that is required. So all these things can be considered and evaluated under the testing phase. So once the training phase is done, next thing is we have to go forward with the evaluation, which involves the testing process. So these are the two different processes. Now let's see one by one like what exactly is training process all about with respect to classification. In fundamentals of data science, the model is built using a historical labeled data. Then also under this we can go forward and provide training, or it learns the relation between the features as well as the class labels. So that is the thing that will be done under the training model. Next is the testing phase. Under testing phase, the model predicts the class data for unseen, or we can say that the invisible data. Then the performance is evaluated based on the accuracy. So this is the evaluation phase and this is the training phase. So these two are very important with respect to classification. Now we did understood like these are the phases that we need to follow, but is there anything that helps us in doing this? Yes, so for this we will be moving forward with algorithms. These are the algorithms which helps us or supports the data in order to represent it in a efficient manner. So we will be moving forward with algorithms. So there are multiple algorithms like decision tree induction as well as then followed by the base classification method. Also the next algorithm that we can see here is rule-based algorithm. So these are the few algorithms that will help with respect to classifications. Thus, let's move forward and understand each and every algorithm and let's study what is the process involved in that each algorithm. But before moving with that, let's quickly understand what are the issues that we face with respect to classification. That's none other than issues in classification. The first issue that we can see with respect to classification is a data quality issue, which is resulted by the noisy information or the repeated information, or we can also say the inconsistency in the information which affects the accuracy. So that's the first issue, that is none other than the data quality. The second issue is class imbalance. With respect to this, what happens is there will be few classes which we build based on our requirements, correct? And these classes will dominate the predictions. So it directly affects the decision making or business intelligence. Thus, it forms a issue. The third issue is none other than overfitting, which means like a model performs very well with respect to trained or during training data, and it will perform poorly with respect to new data. So that is none other than overfitting, and yes, definitely it will be counted under a issue, right? And the next issue is underfitting. When there is overfitting, yes, absolutely, when that criteria misses, we will move with underfitting too, correct? This models very simple data learning patterns, okay? Yes, this is one of a drawback of that. And the next issue is attribute selection or the feature selection. There might be chances of selecting the irrelevant or the redundant data which directly affects the performance or the accuracy of our information, right? Yes, that is the issue. And the next issue is high dimensionality. So this is occurred because of multiple or complex attributes which increases the complexity and which indirectly affects the performance of a data, correct? So these are the various issues that is occurred with respect to classification. Now let's move ahead with algorithms. Yes, the first algorithm is none other than the decision tree induction. As the name itself say, we will be inducing a tree and that tree will go on splitting based on our decisions. So this is an example of decision tree induction where we can see that we will be having a class label and it will be splitted down further with respect to various data sets that is been included under that classification, right? So let's understand like what is this decision tree induction is all about. This decision tree induction is a supervised decision tree algorithm which supports creating a tree-like model to create a class label by repeatedly splitting the data sets based on the most informative attribute or feature. So this is none other than, or this is nothing but a decision tree induction. Now let's see what is the process of this decision tree induction and at each step what happens. Initially, it starts with the best attribute selection. So the best attribute is selected based on the information given, okay? That is our first criteria. Then the data is been splitted into various subsets, okay? That is the second thing that we will be doing here. And the third process is continuing the same process until we get a clear decision. So this is the process that is being involved. For example, let's consider an example of a decision tree for playing tennis. So for that, the main class label that we can consider is a Outlook, okay? So that is my main class label, and with respect to that, I can classify it further into various decision tree based on the data sets, correct? So that is a sunny or a overcast as well as a rainy. If it is sunny, then what has to happen? So that is the process. Yes, then it has to check for humidity. If a humidity is high, then it has to what? So the game has to be cancelled, correct? And if the humidity is normal, yes, they can go forward with playing that game. So this is how we can make the decision by making that decision tree. So similarly, let's see if the class is rainy, okay, or if the weather is rainy, then what happens? Further, it will check the wind condition. If the wind is strong, then can we play tennis? No, right? So we have to cancel the game. And if the wind is weak, then yes, definitely we can go with playing tennis. So this is a small decision tree which says that playing tennis with respect to weather is possible or not. So in this way, for each and everything, we can create this decision trees by taking a class label, further classifying or building a tree by considering a data sets. Clear? So this is the process. Let's move forward. Now let's understand this example in a depth way. Okay. So the outlook, yes, this is a class label we have considered with respect to the weather. That is, it might be if it is a sunny, if it is a overcast, or if it is a rainy. Then what is the further data sets that we have considered? We will be considering the temperature followed by humidity in the same way, wind, and the decision whether we have to play the tennis game or not depending on these data sets, right? So this is a example. Let's move forward and understand how this is built, and through this table what are the criteria that we can consider in order to make the decision. Okay, yes, this is the same thing what we have considered there, whether if it is sunny, then the temperature is absolutely, it will be hot and the humidity will be very high, correct? Thus, the wind, if it is weak, then can we play tennis? No. If the wind is strong, even though we can't play the tennis, correct? Next, similarly, with respect to overcast, again, we will be going with hot or the high humid followed by the wind. Yes, if it will be weak, but can we play the tennis? Yes. Okay. Next, if a rainy case is there and with respect to humidity as well as the temperature, we will decide whether we can play the tennis or not. Okay. So this is my decision column depending on various data sets. All right. Now let's move forward and understand how this is built. Okay. The first thing is to select the best attribute. Yes, we need to select the related feature. Now playing tennis, it is a task that has to be done or it has to be decided. So for that, what are the criteria we have to look at? So it is with respect to weather. If it is with respect to weather, then we have to go forward and check whether the weather is sunny, whether it is rainy, or whether it is a overcast thing. So these things we will be finding by information gain, and that outlook is chosen as the which node? The root node. Okay. Yes, we have a root node. So that is the first thing. Next, the next step is to split the data or split the informations. So how we have split it? Outlook, and based on the attribute, we have considered 3 of the attributes like overcast, sunny, rainy. Further, can we play? Check humidity, check wind. So these are the further data sets that is considered with respect to the first root node. Okay, let's move forward and let's see how the resulting decision tree or the decision rule is formed. If the root node goes with overcast, then can we play tennis? Yes, we can go forward. And if the outlook has an attribute of sunny and humidity both at the same time, then can we play tennis? No. Further, if my outlook is sunny and humidity but wind with normal, then yes, we can go with playing the tennis game. Forward, if my outlook is rainy and windy and the wind is weak, even at those cases, yes, we can go with playing tennis game. Further, if my outlook is rainy and windy and the wind is strong, then no, we can't go with playing the tennis. So this is how we can go with making the decision rule. So this is all about the decision tree induction. So we have understood that there will be a root node and that root node is been selected based on the required outlook with respect to that application. Okay. Here, the example what we had considered was playing tennis. And with respect to that playing tennis, what was the gain or the attribute we have selected? It was completely based on the information gain. And once we are done with a root node, then the different data sets were induced based on our data, that is based on our requirement. And finally, through that requirement analysis, we can take a decision like can we play a game or not. Thus, this is how the decision tree induction works. Great. Let's move forward with the second algorithm, which is none other than attribute selection measures. Attribute selection measures, as the name itself says, by using this, we can select the perfect attribute or feature according to the requirement. And this attribute measurement feature is specifically utilized under decision tree induction. As we saw, there we have to divide or move forward with the attributes, correct? So that's why we will be using this attribute selection measures under the decision tree induction. Alright, when we know that it is being utilized to select the efficient attribute or a feature, it becomes important to understand like how these measures are being set and what are those measures too, correct? So let's move forward and understand primary measures. Thus, the first primary measure is none other than information gain. So till now we did heard we need information gain, correct, under decision tree induction. But what is that information gain? Let's understand it now. So it is none other than measuring the reduction in entropy or the uncertainty after a data set is split on a attribute. Okay. The attributes with the highest gain will be chosen as a root node. Clear? Thus, this is a specific algorithm in which we can see this information gain utilization. Now, let's understand what is the bias that is considered under information gain. So, this bias will give us a trends of information with respect to favor attributes with multiple or many distinct values. So that is the bias thing that we can consider with respect to information gain. The next measure is none other than gain ratio, a refinement of the information gain that incorporates the intrinsic information to normalize the score values. If any score values are present, yes, it can be normalized by using this gain ratios. And the algorithms that can be used or utilized under this gain ratio is none other than primary measures for C4.5. Then the benefits of this is it can be successfully used to reduce the bias towards the multi-valued attributes. Yes, correct. So in many times we have to work with complex data sets, that is with respect to multi-valued attributes, and this is a benefit that we can correlate with respect to gain ratios. So let's move forward and understand next measure, that is none other than Gini index. This is utilized to measure the impurity of a data set. So how is it done? It mainly calculates the probability that a randomly chosen element would be incorrectly labeled. So this is none other than a Gini index. Now let's see the algorithm that is utilized under this. So we can use this CART, which is none other than the classification as well as the regression tree analysis, then followed by the features with respect to this are, it is basically used to perform the binary splits, as well as it is utilized where there is a requirement of computationally efficiency and it is avoided under the logarithmic calculations. So this is none other than the feature of Gini index. Now we did understood the primary measures. Now let's understand what are the specialized measures. The first measure is a I-square, which is represented by x square, and it is used to determine the statistical significance between the attribute as well as the target class. And in order to do this, we will be using the Chade algorithm. Clear? So this is a advanced one. Okay. The next measure is reduction in variance. So yes, this can also be done, which is used for regression trees to select the splits that is best decreased to the variance of the continuous target variables. Clear? So this is a second measure, and the third measure that we can go forward is none other than MDL, which is nothing but minimal description length. So this is used to selecting the attribute that results in the simplest tree requiring the fewest bits to encode the model and its exceptions. So if any exception is there, then it has to be considered and modeled according to our requirement. So these are the special measures that is available and can be utilized based on our requirement. But as the name itself says, these are the complex or advanced measures which requires more information with respect to data as well as the algorithms too. So this is all about two of the algorithms. The first one we have discussed is decision tree, and the second one is the attribute selection measures. So we have successfully completed these two algorithms, and in our next session we will be studying these algorithms, that is base classification and a rule-based classification. Then we do also discuss the lazy learner algorithm. So these are the things that we discuss in our further session. So this was all about today's session. Thank you.